right. Thank you so much, everyone, for coming for the talk. I'm Sriram Sridharan, co-founder and CTO of Rocks. Rocks builds revenue agents for the Global 2000. As you all know, we are in the middle of a tectonic shift that's happening in the industry. The whole of MongoDB local has been about AI and how agents are transforming work. Very similarly, like how coding agents went and 10x productivity of engineering teams, we build revenue agents, and we believe this will 10x the productivity of customer-facing teams. When I say customer-facing, what do I mean? These are people like account executives, customer success, account managers, SDRs, BDRs, so on and so forth. So in this talk, I'll go over what do I mean by revenue agents, what is the revenue stack, how has it evolved over a course of time, how new AI architectures are emerging here, and what do we build, and how does Rocks take it from pilot to production in enterprise customers. Let's get started. All right. So about Rocks, our mission is simple but ambitious. We want to secure and grow the world's revenue. We have assembled the best team here. We are from hyperscalers, MIT, Stanford. We are backed by the best investors, GC, Sequoia. They are all part of our journey to actually redefine this revenue stack from the ground up. And we work with the best customers. MongoDB is a customer of ours that we're working with. We also have other customers across multiple different verticals, from financials to industrials, semiconductors, sovereign AI stacks, B2B tech, so on and so forth. All right. So what is the revenue stack? What has happened historically over a course of time? In the 1990s to 2000, when everything was on-prem, CBIL was the biggest CRM at that point. It was hard to configure, long time to implement, but it's very powerful. But with the advent of the cloud, just AWS, Azure, GCP, Salesforce, which was built for the CRM for the cloud, took off, became the predominant CRM, and it's still the predominant CRM today. But what happened was the best revenue teams split the system of record and the system of action. So the Salesforce became the system of record, but the system of action, where reps work on, became multiple different point tools on top of the system of record. This involves things like Clary for forecasting, SalesLoft and outreach for engagement, and then Gong for conversational intelligence, Gainsight for customer success, so on and so forth. Now, with the advent of Cloud 2.0, which is what we call as with the advent of data warehouses, like Snowflake, Databricks, Redshift, so on and so forth, the data from the CRM moved into the warehouse. Not just the data from the CRM, but also multiple different systems like support, product usage, marketing. All of the information moved into the warehouse. The reason people did it is because they wanted to have a unified view of their customer across multiple different data systems. Like, for example, if I want to know how much is my customer using, do they have any support tickets, so that if I go into like a QBR or an MBR, I have full information on what is going on with respect to this customer. So the best revenue teams, including MongoDB and other customers, actually broke away from the CRM and moved into the warehouse. The point tools still remain. They are all the point tools where people have to go in and actually do work on the system. The system doesn't do any work for you. Now we are entering into this AI era. What we believe is there is a fundamental opportunity to transform this entire layer from the ground up, where the AI agents will do work for you instead of you doing work on the system. We'll talk more about that and the architecture in the following slides. But this kind of sets up the historical shift of how things have happened over the next few decades, or the past few decades. So if you look at it, there is three different problems. One is the data is fragmented, as I mentioned, across multiple different data systems. You have your support, your CRM, your marketing, your product usage, or so on and so forth. The best revenue teams have moved to the warehouse, but many people have not. Like, we work with paint companies and like packaging companies. They have not even started moving into the warehouse yet. So our first hypothesis is that the warehouse is becoming the system of record. But the workflows that reps do on a day-to-day basis is completely inconsistent. It's manual. Reps spend like hours doing manual research on the internet. They actually prep for meetings, and updating their CRM is a chore that they have to do today, and writing and rewriting the same emails again and again, and chasing information across teams. If you look at the chart on the right, There's a study from BCG which says that only 20% of their time is actually spent selling, like human-to-human selling. The rest is all administrative and operational drag. That is actually completely ripe for AI augmentation or automation. So the gap is very clear. We have a lot more data than ever, but very less leverage. I'll repeat, we have a lot more data, but very less leverage right now. The only way to fix this is if you have a system that can unify the data and context across multiple different systems and have the ability to run consistent workflows across the entire organization. So this is why the architecture matters. So enter ROCs. So what we are is a fundamentally different AI native architecture that's built to unify your context and have consistent execution across your entire revenue lifecycle. So we are the first AI native operating system to do this, and we have 4 different layers. First is the data layer. Now, we are built warehouse native. So if your data is already in your warehouse, ROCs agents can just work on top of that data. If not, we will work with you to pump the data into your warehouse from multiple different systems. This is not just structured systems, like business systems, but also like unstructured data, which is 10x or 100x more than structured data, which contains all your call transcripts, emails, public documents, all so on and so forth. Then you have the context layer. This is probably the most important layer of all, where even if you have data from multiple systems, you need to understand how to map these entities across these different systems to be a universal single entity. We call it the knowledge graph. It's a widely known name. We'll talk more about how we build the knowledge graph. But this is not just across business systems, but it's also unstructured data out there. Because LLMs are very good at extracting entities from unstructured data and tying it to the context layer or building the knowledge graph on top. We'll talk more about how we build it in the next few slides. Once you have the context layer, it's a thin metadata layer with pointers to the data. Now you can run AI agents on top that can do your entire revenue lifecycle from research to campaigns or sequences, to meeting prep, to deal management, to renewals, so on and so forth. Again, these are all not DIY agents, which is what other companies do, but these are turnkey agents that are already tuned for the entire revenue lifecycle. And we deliver these agents via apps, which could be iOS, MCP, API. We have our own web app, and so on and so forth. Now, this is the full ground-up rebuild, all the way from the data layer to the app layer. This architecture is what enables us to do all this consistent execution at scale. All right, let's go one step deeper now into the platform architecture. So if you look at how we have built, we have a clean separation between the customer's data plane and our execution plane. On the left, you see is the customer's data plane, where it has their warehouse, identity provider, CRM support systems, etc. They have 2 options to share data with us. Either they can pump the data into ROCs' warehouse or lakehouse, or we could integrate with their systems directly. The widely used protocols from Snowflake and Databricks and so on and so forth, where you have Delta Lake or Iceberg, or, which is zero ETL these days. Now, on the right side, we have our logs platform, which contains our own compute, intelligence, orchestration, content ingestion, and we have our own lakehouse. Now, MongoDB is a key strategy as part of our lakehouse. We recently moved from Dynamo to Mongo, mainly because for high flexibility and throughput that we needed. And also, Mongo has document limitations of 16 megabytes, whereas Dynamo has 4 kilobytes. It's very architecture, we had to chunk up all the documents and store the memory there, which is moving to MongoDB is much easier for us to do so. All right. Now, I told we'll talk about the knowledge graph. Let's go one step deeper, how this is built. So we have data that is coming in from multiple different data systems, not just structured, semi-structured. It could be unstructured data as well. It could also be public internet documents. So we ingest all this data, do entity mapping. Now, if you look on the right side, that gives an example of one table in the knowledge graph that we construct. So assume this is a Salesforce account ID, and we have a UUID that we give in ROCs for that. But the same account ID is mapped across Zendesk, which is your support, your usage, product usage data, which could be in your warehouse already, Gong, and a public internet article. It could be an article about a company that raised funding and got acquired. We extract that entity and merge it into the knowledge graph. Now, this happens seamlessly, like we entity extract, resolve, and then like streaming update it into the knowledge graph. Now, what this Rocks gives you is something that you were not able to do before in this space at all. You could now run a query which says, a manager comes and says, hey, how much of my top used accounts in the last call mentioned a competitor? There's no way to do this today. It takes you hours because you have to go to your CRM, find the top accounts, go to your product usage, find out, okay, who are all the top users, go to your last call, gong transcripts, extract the competitor mentions. No way. This takes you like hours to do this today. In Rocks is one single prompt that you can do, and it goes and gets you all this information from multiple different systems. All right, so we talked about the knowledge graph, which is the data layer. That's the foundation. Now let's talk about the intelligence layer. We talked about multi-agent orchestration in the previous talk. For people who are here, yes, that's what we do. So instead of having a single general purpose model that actually does everything, our workflow has a coordinated set of agents, each of them responsible for a specific part of the revenue workflow. So every workflow, there is an orchestrator agent, that's the brain that sits in between, which runs the latest and greatest models out there. It plans the workflow, routes the tasks, manages handoffs across the different agents, which do research, outreach, deal management, email composing, getting a slide deck out, formatting, even tone is a separate agent that we have. So all of these agents have a shared common working memory that they pull from. We use MongoDB for that. And then they all have, they all can pull the long-term memory from the knowledge graph. So the knowledge graph is a single layer where we can apply permissioning on top so that you have complete governance on top of it. And you can also audit what the agents are doing from that layer. So that's what the unified layer kind of gives you. So the result, what is the result? The result is a predictable, repeatable execution engine that you can scale across thousands of accounts in parallel because each step is handled by an agent that is best suited for it. All right, now let's take a simple example and see how this works in practice. So I mentioned before, if you have a rep that has to go and find out for an account how much is the usage, what is the public signal that has happened, and figure out, put up a slide deck. If you go into it, then what happens is an orchestrator agent gets this query, it triggers like a public research agent, a private research agent, does some reasoning on top, formatting on top of that, and then it gives you a slide deck. Now, if you have built AI agents in production, you know this is only one part of the problem that you're solving. There is an invisible asymptote that you have to cross which actually helps you run this at scale. Now you have to run it for, let's say you have to run it for thousands of accounts. We have hundreds of thousands of accounts to run in production, one. Now security, like you have to ensure that you have RBAC, you're preventing prompt injections, permissioning enforced correctly if you're running on top of the warehouse. And reliability, like models fail all the time. It's very easy to build something that works from 0 to 90%. Every 9 you have to add on top of that is 10x or 100x more work to actually make it to work. So this models fail all the time, so you have to ensure that infrastructure failures are taken care of, you A/B test. This quality, this is super interesting because you have to pick the right model for the job, but if the model fails, what's the fallback model? So you can't use the best models all the time. You need to understand which models are equally capable. Like a GPT OSS is not the same as Kimi, or it's not the same as GPT 5.2. They're all different. Like you need to understand how the fallback models actually work. You have to have guardrails so that it does not say things that is not supposed to be said. Then you have to do evals on them. The models are the business logic, so you have to do evals to ensure that since this field moves extremely fast, you have to, if you're going to a new model, you have better evals to ensure that the models are doing the right thing. You have to trace and then ensure that the agentic loop max turns hyperparameter is tuned properly. Then you have performance. The most important thing is the cost curve. As I said before, it's very easy to spin something up and make it to work, but at scale, if you don't understand the cost curve, don't do it in production. It's extremely pricey if you have to really understand how to bring the cost curve down if you're scaling it to hundreds of thousands of agents. And this is where we come in, and that's our expertise. All right, so as I talked about scale, like Rocks, we did 4.2 trillion tokens last year across all the customers. To give you a frame of reference, OpenAI published a set of companies that were trillion token users, and we were in the top 20. And we are the only revenue agents in the top 20 doing so many tokens per year. All right, so with that, scale is a first-order citizen for it. It's a first-order constraint that we have to optimize for. So effectively, we have to have techniques like context compaction, push down the retrieval to the storage system to minimize the amount of data that comes in, standard techniques to ensure that we don't like shove tokens into the system and to get what we want. The third thing is, of course, we have to do cost-aware, limit-aware optimizations. Each of these models have rate limits, by the way. You can't like just spam them with what you want. You have to understand what the rate limits are and how do you like fall back like properly to the next model. All right, so we talked about the motivation. We talked about the architecture. Let's talk about adoption. Like, how is it actually adopted in the enterprise? You know, coding agents are widely adopted. How is the adoption going on with revenue agents? So every leader on the go-to-market space knows that there is a disruption that is coming in the sales, marketing, and service layers. Like, the vision is very, very clear. You have to increase revenue per rep. You have to ensure that there is growth without headcount. And then you have to modernize your go-to-market stack. Your go-to-market stack probably has like 500 apps, SaaS apps today. You want to modernize it to start using AI apps. All right, but the reality today is very different. Like I don't know how many of you have seen this MIT study where 95% of these pilots fail to reach production at all today. The reason is because AI is just bolt on. It sits outside the core systems. The time to value is very slow in incumbents, and then there is a behavior change that needs to happen for people to start using these AI systems. Let's look at the landscape of how things are with respect to these three categories of solutions. First, you have the incumbents, which is the legacy CRM solutions. What they have is the complex, costly customization. The time to value is very long. Today, it's like 12 or 18 months if you're deploying a legacy CRM implementation. And they have DIY agents where they ask you to build your own models, build your own prompts, select your own models, and then like build your own agents. That's just ridiculous in my opinion, where there's like so many things that you have, there's so many variables that you have to know for you to get something to even work in the first place. So they don't work. The second thing is bolt-on solutions, where there's a heavy integration burden. They don't have enterprise-wide context. What you end up with is, instead of a SaaS 2.0 sprawl, you'll end up with an agent 2.0 sprawl, because there's so many agents flying around and nobody knows what agent does what in the enterprise. That's where we believe we have a future-proof AI-native architecture. We cover the entire revenue lifecycle, and we can be a long-term partner with any enterprise that wants to transform their go-to-market organization. All right, how do we do this? First, we don't expect IT teams or end users to configure their agents or tune their prompts. We come up with our own forward-deployed engineering team, which is a combination of engineers and consultants who are invested in the outcomes of the customer, not just a platform that we sell. So when we start with a focused pilot with a specific team. Then we actually train the people on the team to start using these agents. Then the interesting piece happens, which is we take a workflow that actually works on an org, and this workflow is very different than MongoDB. It's very different than Philips or Siemens that we actually sell into, and it's very different than WSP or like Sovereign AI, because the go-to-market process is very different across different organizations. You take that process, which works, and scale it across the entire organization. The point is to make your best rep better and the remaining closer to the best. Then once that works, then we actually go to the other teams and kind of make it the new, institutionalize it across the entire platform. So that is where we believe is, that's the way we believe is to actually like transform your go-to-market org completely instead of just selling a point tool or a platform. Now, if you look at ROI, how this has been happening across the industries, like across all the customers that we work with, there is a reduction in meeting prep time. There's increase in number of meetings booked. There is also like higher conversion, better targeting, shorter ramp times, consistent execution across the entire org. We are also working with MongoDB to increase the number of meetings booked. Hopefully, we'll partner with them to actually be part of their already incredible success story. Now, if you look at a specific example, which is Ramp, Ramp is the fastest growing SaaS company ever and have the tightest go-to-market execution. Even there, our revenue agents were able to find 15% more six-figure deals than what they have today, which is crazy. Anyways, this is how we believe AI agents are fundamentally transforming the way revenue teams work. We're still at the very beginning of this shift. This is a long journey that we are kind of getting into, and we are at the cusp of what is happening. As I mentioned in the beginning of my talk, as coding agents 10x the productivity of engineering teams, we believe revenue agents will 10x the productivity of customer-facing teams. Thank you all for your time today. I'm more than happy to take any questions.